Hi guys, welcome to our video on finding the derivative of a logarithmic function of any base. So let me just scroll real quick actually to our other one. So our previous video we saw these rules, and I just wanted to scroll to eyeball them and state, well, look how these ones compare when it's a different base than the natural base of e, so any other base, so we usually write log base whatever. Then notice it's still 1 over x, but then times by the natural log of whatever the base is. And then same deal with absolute values. It's still 1 over x, so that part's still the same, but then times the denominator by the natural log of whatever the base is. Okay, similar to with our exponential ones too. Let me scroll so back to these ones. When we had a to the x, notice it times the natural log of a. So this was an exponential function. Well, the logarithm is just doing the denominator by it. So it's, instead of putting it up top, put it down below. Okay, so and also it still is a little bit different rule. Log means put your 1 over your x like that, and then the natural log of a down below. And then this is the chain rule portion where you put the u of x immediately down below, and then the derivative of it up top. But then again, just remember to multiply the denominator by the ln of whatever the base is. All right, so for instance, let's break this down. All right, so in number 1, to find this derivative, well, if it's ever blank like that, it really is log base 10. So there's two special bases. So log base 10 of x is just log of x. Log base e of x is ln of x. So these are two special ones. Otherwise, they keep the number as is. All right, so this might help on this problem where we can see, okay, well, if I wanted to find the derivative, dy dx, again, I know the derivative of a log function is to put that down below. So we put this x in the denominator. The derivative of this x is 1, which goes in the numerator. But then because the base is something other than e, I just make sure to multiply that denominator by ln of whatever that base is. And that's it. That's all there is. Okay, so let's see some other scenarios. So on this problem, we have c of q equals 10 times log base 2 of the absolute value of 20q squared minus 3q plus 4. All right, so to find this derivative, this 10 is a constant multiplier, so that means it would just be hanging out. So c prime of q equals 10, and then I see a log function, so I know the derivative of that is to get a fraction ready and put this whole thing in the denominator, so 20q squared minus 3q plus 4. And actually, sorry, I probably shouldn't have put that parenthesis there yet because I probably need more room. Okay, so it looks like that. And let's go ahead and put that in parentheses to show it's all, that would be all in parentheses because other stuff's going in the denominator soon. But once we have this here, I know, hey, do that derivative to put it in the numerator. So 2 times 20 is 40q. And then minus 3. So that's the derivative of that expression, just instantly written up top. And then I think, oh, the base is 2. It's not ln, so just make sure to multiply the denominator by the natural log of that base. So it looks like this. So one big fraction, and then that looks good. We can box that up and be done. Okay, so often it's one giant step. So that works out in our favor. Okay, let's look at two other kind of weirder scenarios. Okay, so in this number 3, notice it is a quotient, so something divided by something. So that means I want to set up my high, and I missed there. So there's my high portion, and then my low portion right there. Okay, so I always use my same old rule. So my h prime of y is my low d high minus my high d low all over my low low. There we are with the parentheses, boom. Okay, and then now I usually continue using my colors. So the high stuff, keeping in blue. The low stuff, gonna change to red. Okay, so there's all that. And then now I'm gonna plug in what I can into this. If I need scratch work, I'll use it, but let's see how this goes. Okay, so the low portion is this whole thing. Okay, and with the low, yes, let's go ahead and get some scratch work right away. The low, so is e to the negative y, and that's fine. But notice the 2 on the y power. Well, we could leave that as is. You could also move it to the front. So we had a rule for this. Remember, when you have a power, you can move that. So plus, you can move that power to the front of the log. Like that. And so it might make it easier to do that derivative. So it's up to you if you wanted to do that. It would give you the same answer, but let's go ahead. I'm going to use that rule. So as a reminder, I'm using this rule. If you have log base b of something raised to a power, and I usually use just capital M for the something, then that power can be moved to the front. And that's what I'm doing here. So the y was squared, so that power was 2, so I'm moving it to the front, just like that. And then that way, might as well, let's go ahead and get our derivative of the low. So the derivative of an exponential is itself, so e to the negative y, times the derivative of the power. So that would be times negative 1. And then the base is e, so that means this is all I have to write. And then I have plus, this 2 is just hanging out, so it's just plus 2. The derivative of the log portion is, well, I know the y would go in the denominator. The derivative of y is 1, which would be in the numerator. And then the denominator also needs to multiply with the natural log of 5 because the base is not e. Okay, so that's what this one looks like. And to clean it up one more step, the derivative of the low, so this we would change to negative e to the negative y plus, let's do the 2 times 1 to get it just to be 2 up top, and then y natural log of 5 down below like that. All right, so that was that big step. So let's rewrite it now. So we have negative e to the negative y plus 2 over y natural log of 5. Okay, so that was the, oops, sorry, erase that. I was focused on the derivative. That's not the derivative. I just want to put the low on, sorry. So just the e to the negative y plus the log base 5 of y squared. Okay, so, and this one I'm keeping the square on it. Again, you can move it to the front just like I did in that step right there. Okay, and then we have the derivative of the high. Well, the derivative of the high I think we can take without scratch work. So the derivative of 3y is 3. The natural log of 12 here, that's just a number. So be careful. So the derivative of a natural log of just a constant, that would still be 0 because the natural log of a constant, that is just a number. So you have to be careful. So just like if it's the derivative of so if they said find the derivative of e to the 4. Well, this is still just a constant. So you need to make sure that you see that there's a variable involved to get a derivative that's different than 0. So be careful there. So the natural log of 12, so don't put 12 down below, and then I guess the derivative of 12 would have been 0, so you should get 0 either way. But it would be just 3 as the derivative for the derivative of the high. Okay, so again, we're using that rule. The derivative of a constant, ln of a number, is just a number. So the derivative of a number is 0. Okay, and then minus the high portion, which is the blue there, the 3y minus ln of 12. And then I need more there. And then now the derivative of the low, which was this thing that we found early on. So negative e to the negative y plus 2 over y ln of 5. And then all over the low one squared. So this getting squared e to the negative y plus log base 5 of y squared squared. Okay, and then this should be okay. Okay, so usually the crazier it gets, the less work there is once it's plugged in. So I'm thinking this should be fine. If we need to, we might need to distribute this 3. We might need to FOIL this out. But chances are, I would say, is that it's done at this point. Okay, so let's do one other one in this video here where we have this g of r function. Well, notice I've got a radical, multiple radicals, so I probably want to change that. So let's rewrite it before anything. and write this as parentheses ln square root of r, let's change to r to the 1/2, plus log base 3 of r minus 2 plus 19 to the r, all to the 1/3. So we saw it was a cube root. So I'm rewriting. So I had two radicals I wanted to rewrite. And now it looks like this. All right, well, I'm going to use my rule again, this one. So I'm saying rule. There's lots of rules, huh? So I'm using my rule for the power that's involved with logs. All I want to do is just move this to the front first. And that's all I'm going to do in this step. So it's still g of r equals 1/2 natural log of r plus log base 3 of r minus 2 plus 19 to the r, all to the 1/3. Okay, well, it certainly looks like I need the chain rule because I have this whole expression raised to a power. So that means this, everything in blue should be u. So I've got u is 1/2 natural log of r plus log base 3 of r minus 2 in absolute values plus 19 to the r. Okay, so that's my u, and like always, once you set your u, go ahead and get your derivative of that u with respect to whatever the letter is. So it's du dr in this case. Okay, so the derivative of this, well, the 1/2 is just hanging out. The derivative of the natural log of r would be put the r in the denominator. The derivative of r is 1 in the numerator. There's that. And then we have plus. I have a log function again, so it's saying, all right, the derivative is put that expression, the r minus 2, put it in parentheses, though, at this point, not absolute values, so parentheses r minus 2 down below. The derivative of r minus 2 would be 1, so put that up top. But then because the base is not e, make sure to multiply that denominator by the ln of the base. So like that. And then another plus. The derivative of an exponential function is itself, so it's 19 to the r. But then because the base is not e, this time around we multiply by the natural log of that base. So it would be times the natural log of 19, like that. And you can put parentheses, those are optional. Let's go ahead and do it like that. Okay, and so now I have everything. This right here, we would simplify. So this is the only thing. The 1 would times the 1 and the 2 would times the r to make that a single fraction instead of one fraction times a fraction. But other than that, it's ready. So let's set this up as g of r equals, so everything in the blue I said was u, and it's raised to the 1/3 power. And so now I can do this derivative. G prime of r is, using the power rule, 1/3, and then our u still there. Minus 1 from 1/3 would be negative 2/3 times the derivative of that u with respect to whatever letter, the r. Okay, so that's all of it. And so now let's plug that in. I'm going to put it to the side since I'm a little out of room. G prime of r is 1/3 the u. So all of that u that we said before. So it's 1/2 natural log of r plus log base 3 of r minus 2 plus 19 to the r to the negative 2/3. There we go. So that's that portion. And then times the du dr. Okay, so parentheses. We said this would just become 1 over 2r. And then plus 1 over r minus 2 times the natural log of 3. And then plus 19 to the r natural log of 19. Again, I kind of ran out of, but barely able to squeeze it, so thankfully I was able to. But then now I think we are done. So typically we stop right there. Let's box it up, and that's it. Okay, so that's it. So again, just like most of these videos in these last couple sections, it starts off with the easier ones, medium, and then some lengthy work because of quotient rule, chain rule, and product rule. Okay, anyway, but that's it for now. That's it for this section. So if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.